Okay, good afternoon, everyone. Welcome to the afternoon session. I think it's the first one after the break. So, my name is Michael Pogrubitsky. I'm a sales engineer from Checkmarx, one of the sponsors here. So, just a few words about Checkmarx. We're a vendor in application security space. We do software that helps you to deal with application security issues, different aspects of application security, things like static analysis, software composition analysis, and stuff like that. And in this session, the session is about 50 minutes long, so it's, I think we have enough time to cover everything. And in this session, I'm going to demonstrate to you what you can do with our platform, and you're more than welcome to ask questions. Stop me at any time, ask, don't be shy. Everything that you want to know, I'm here to help you with that, okay? So first of all, what I'm going to present to you here is our new, we call it now, the brand new name for it is Checkmarx One. It's the comprehensive application security testing platform that is fully cloud-based, so it's a full SaaS service. You can subscribe to it and access it immediately, basically. And in the very simple scenario, nothing needs to be deployed on your end. So basically, you can, once you get access to your account, to your tenant, you can start scanning your code and getting some results, and this doesn't require from you any additional effort. So I'm just going to start walking you through the platform and going through different aspects of application security testing, how you can accomplish them using the platform. So what you see here is the view that you get as a user when you log in. It's basically a personalized dashboard of all the projects that you as a user have access to. It's basically kind of mapped to the bits and pieces of code that you can scan or you have scanned. And you can see the high-level results here. So you can see what's the origin, meaning where the scan came from. What's the source type? The source type can be a zip file upload or a connection to one of the supported platforms. So, and I'll walk you through this as well. And you can see the high-level statistics about the latest scan. Now, what you see here is basically, it actually depends on the kind of access that you have. So you can define distinct groups, and users can belong to specific groups, and then they can only see what they are supposed to see. So the projects that belong to the same groups. And this can be integrated into your identity provider. So it can be integrated into your LDAP or any SAML 2.0 compliant identity provider. And this way you can perform both authentication and authorization outside of the Checkmarx platform, and you can basically manage your user access outside of the Checkmarx platform, which is what most of our enterprise customers do. Okay. So what we're looking at here is the project level. You can also do a high-level aggregation, so you can actually bunch projects together into what we call applications. And an application is basically just a collection of projects, and all the statistics, you can roll them up from the individual projects to the application level. So this basically allows you to define a high-level entity which would correspond to your business applications, and you can organize the reporting of all the combined statistics into that level, and this gives you kind of a high-level visibility. So you can assign projects to an application, and you can do it by just project name, and then you can select from existing projects, or you can do it by tag, so you can tag projects. And if you define an application to be using a tag as the ID of the projects participating in it, then even future projects that you add with the same tag will be associated with this application, and you can get statistics reported there. Yeah.
Projects will be Azure reports, right?
Well, in most cases, projects are mapped one-to-one to a repo. Okay, so a repo can reside anywhere, you know, and I'm actually going to show you to which environments we currently natively integrate, so you can define this mapping one-to-one in a very simple and seamless way, but it doesn't have to be like that. Basically, the easiest way to start scanning is by just defining a project as a vanilla project, so you can do it like this. And you just give it a name, you assign tags to it, and then you can upload a piece of code which can come from anywhere. So you can potentially combine multiple repos into the same zip file, and you can upload it, and it will be treated as a project. But you're right, in most cases the project is mapped one-to-one to a repo. Okay? Yes, yes. So there is a great deal of flexibility when it comes to defining the projects. There is one particular way of defining projects that I'm going to show you now, which is doing this mapping exactly one-to-one to a repo. And it has certain advantages, but you need to remember that it doesn't have to be like that. So another way of defining a project is by importing projects from one of the environments that we support natively. So we support these environments natively, and the version that I'm showing you now is only integrating with the cloud versions of these. But we already have in the pre-release environment integrations with the on-prem versions of GitHub and GitLab. And in the near future, we're also going to support on-prem Bitbucket and on-prem Azure DevOps. So basically what happens here, so for example here I went to GitHub. Now when this is done for the first time, and this is something that you're not seeing here because I've already done this once, this is something that needs to be done once. But when you do this for the first time, what happens is that the Checkmarx AST platform is requesting permission to access your GitHub account, and this only needs to be done once. But once this is done, it goes to the next step, which is selecting the organization. And then at the next step, you can select one or multiple repos that you have access to as a user. And then you can continue to creating the projects on top of the repo. Now, at this step, this is actually quite interesting because what you can do here is you can set up the automatic scanning in a way that every time there is an event like push or pull request into a designated branch, and you can select multiple branches here. So you can select a bunch of branches. So anytime there is an event like this, push or pull request, a scan will be triggered for that particular branch, okay? Once you finish this wizard, you already have a project defined in Checkmarx for which the scanning is already set up automatically. So you basically don't need to do anything. And anytime there is a new event such as push or pull request into those branches that you designated, there will be a scan automatically triggered. Okay? So let me kind of showcase it for you on kind of a real world example. So this is a project that I defined on top of my GitHub repo. So if I go into the project itself, I can see that now I'm in the context of the master branch. So within the project, you can switch between multiple branches. So now I'm in the context of the master branch. I can see that originally when I created the project, so this is the bottom line here, I immediately ran the scan. And I can see that I had 126 high severity vulnerabilities, 77 medium, and 34 low severity vulnerabilities. So now I decided to fix some of these vulnerabilities. So what I've done, I created the change in my Visual Studio. I created this change by creating a new branch. So I created a branch, I called it Security Fix. I made some changes there. I pushed a few changes into that branch. And by that time, I decided, okay, I'm done with these fixes. Now, As far as I was doing this within the context of the security fix branch, nothing was happening in Checkmarx because I didn't define the security fix branch as a what's called protected branch, okay? But then I created a pull request into the master branch. So when I create the pull request, what happens is, so this is the pull request, and when I created the pull request, a Checkmarx scan was initiated, and the pull request was actually paused until the Checkmarx scan is done. And then what I've got here is kind of a summary of all the newly discovered issues or fixed issues. So it's not everything, it's not all 200 odd issues that I had there. Only the ones that are either new or fixed, okay? So I can be very focused in my understanding of what's happened here. And now I can decide what to do. If I'm satisfied with the outcome, if I see that I actually achieved what I wanted to achieve, so for example, in this case, I was looking for fixing some issues. In other cases, I might be just performing a general functionality enhancement, and in that case, I would be interested to see that I'm not getting any new issues, okay? But if I'm not satisfied with the outcome, I can make some additional changes into the security fix branch. I can recreate the pull request. It will relaunch the scan, so it will produce another scan. And I will get another comment into the pull request. And this is until I'm done, until I decided, okay, now I'm done. So I can see, if I go back here into the Checkmarx platform, I can see that scan that was done in the security fix context. And you can see that its origin is a pull request webhook, okay? But once I'm done with that, once I decided that my change is good enough to proceed, so I merge my pull request, what effectively happens then in the context of the main development branch, it actually equals to the push into the main development branch. So what happens then, if I switch back to my master branch context, I can see that there is another scan here, now in the context of the master branch, and its origin is push webhook. So basically the merged pull request results in another scan, now in the context of the main development branch. Okay, so this way I kind of close the cycle. You can see that now I have fewer high severity issues because I fixed some of them. I actually also created another one, a new one, which I probably should have fixed as well, but you know, I was too lazy. But that's kind of showing you the this create feature branch, pull request, merge, cycle, and how it gets closed in the Checkmarx platform. Any questions on that? Okay, so let's have a quick look at the actual results. So the types of scans that this platform is currently capable of doing are 3. So we have SAST, Static Application Security Testing Scanning. So this looks for vulnerabilities in your custom code. So things like SQL injection, cross-site scripting, command injection, you know, privacy violations. Whatever happens within your own code, that engine will be looking for these types of vulnerabilities. The other type of vulnerabilities that we're looking for are known vulnerabilities in the open source components that your software might be referencing. And I'm going to go into more details for each and every one of them. And the last one is looking at any types of security misconfigurations or vulnerabilities in infrastructure as code files. So if you have Docker files, if you have Kubernetes files or Terraform files, etc., we're looking at certain types of security misconfigurations there. It can be some rules that could be tightened. It can be things like unlimited resource consumption and stuff like that, or too high resource consumption that might require your attention as a security professional. So let's have a look at, first of all, at SAST. So from SAST perspective, the first thing that is worth noticing is the breadth of our SAS support. So we actually support a huge number of languages and frameworks. from SAS scanning perspective. So this is really important because the quality of the results that you're getting from your SAS scanning really depends on how intimately familiar the vendor is with the specifics of the language or the framework. And we're working on this all the time. So we're releasing new versions of this SAS scanning engine on very, high pace, like every month or so, with new frameworks, new versions of the frameworks, sometimes even new languages and stuff like that. So, for example, we started supporting Kotlin only 3 years ago or something like that. Scala is relatively new. Golang is relatively new, etc. So this is in terms of what we support. So now let's have a look at the specific results. So if I go and look at my SAS results, so this is how it looks like. So it's broken down by the language. And then you go into the individual vulnerability families. And you can see, let's say for SQL injection, you can go into the specific vulnerability. And what it shows you here at the top is the actual vulnerability flow. So you can click through and you can see how it propagates. So in this specific case, there is some stuff taken from the input. So it's actually taken from the cookie. And then it propagates all the way through to the database access. And this database access is not properly sanitized for SQL. And that's why we identify this as a potential SQL injection. Now, we pay lots of attention to providing relevant and helpful information to the user, to the developer, because not every developer is a specialist in application security. So we provide a fairly comprehensive description here, which is in context and trying to provide you with the most relevant information about what's the actual problem here. Now, we also provide a more detailed article, knowledge-based style article on that particular type of vulnerability. And it shows examples of both vulnerable and fixed code in the language in which your code is written. So in this case, the code is written in Java. So therefore, we show these examples in Java. On top of that, we also have the link to our interactive secure coding learning platform. It's called Codebashing. So Codebashing is an environment in which developers can actually learn about secure coding. And it can be used on in its own right. So it has its own number of courses, and you can take these courses at your free time. And admins can actually define assessments there as well. But from the integration perspective, what happens here is that once you stand on a specific finding, you can go and you can switch to the lesson itself, and you can launch the lesson from here. And all lessons look pretty much the same. So initially what happens is you're taken to a pseudo application in which you're told what to do. So in this case, it actually tells me that, okay, now let's perform a login, and the credentials are given to me on the left-hand side. So I actually need to follow the instructions. And it's not a video. If you make a mistake in the credentials, it will fail. Okay. So it failed here, but now it also tells me what's happening here, and it also shows me at the bottom how the downstream SQL statement looks like given the inputs, okay? So if I keep putting the credentials here, it will show you in real time how this changes. So let me put the credentials again, but now it suggests to me to put an extra quote sign at the end of the password. Okay, so now it fails. And I can see exactly what is the SQL statement. And the SQL statement here failed because I have this extra quote sign and it's not been properly escaped, and that's why it actually has a syntax error from the SQL language standpoint. Okay, and now it takes me to the code itself, and it shows me how the original code looks like. So as you can see, there is a SQL statement here built by simple concatenation of inputs. So that's obviously not something that is very recommended to do. There is a little bit of an explanation on the code itself. And what's also important here is that this part is where it becomes language specific. So here we're in the Java context, so it's showing us the example in Java. And now at the next step, it takes me to the same code, and it shows me how this code should be fixed in order to use the right. Yeah, so now it's just it just highlighted the problematic statement. Yeah, now it shows me how again I can play with different inputs. Okay, and now it tells me to put this particular statement, so it will actually allow me to log in without providing the valid credentials. And this is all due to the fact that it has a SQL injection in there. Okay, so I was able to get in, and you can see why. Because the password is empty, but it has this OR statement, so end takes precedence. So this entire thing from email to the end is considered as one statement. And although it's false, the next statement after it, which is true, is 1 equals 1. And this is why it succeeds. And then it just cuts off the rest of the SQL statement by putting this pound sign in there. And again, it shows me, it gives me some explanation. And now it's going to show me how this should be fixed. So this is now using prepared statements. And this way, my code becomes immune to any kinds of invalid characters that could be specified as inputs. Okay. So this is just an explanation. And that's it. This is the entire lesson. And at the end of the lesson, there is a quiz question. Anyone wants to give it a go? Let's see. Yay. Okay, so you passed the test. So again, this is how a typical lesson in Codebashing looks like. As you could see, it's taken me, 7-8 minutes to complete. Doesn't require much, but what's most important is that it gives you this ability to learn more about this particular type of the issue while you're looking at the results of the scan.
Codebashing comes with the same licensing?
It's an add-on. It's an add-on.
Oh, it's an add-on.
Yeah. But it's not expensive.
Nothing is expensive.
Okay, so this is in terms of looking at the results and getting some help with the results. Now, in terms of triaging the results, so once you're looking at the results, you kind of, basically you want to translate this into actionable, into action. So initially, all the results are discovered with the state to verify. Now, once you look at the results and you understood that the result is actually a valid result, you can confirm it. And this basically says, okay, now I confirm that. And you can actually set up a workflow where confirmed results get translated into, for example, Jira issues. So this is something that you can set up within the product. Now, if you think that the result is not exploitable, if it's a false positive, you can mark it as not exploitable. Now, what happens with the results that are marked as not exploitable, they basically are not getting rolled up into the statistics. So they're not counted against thresholds. So we'll talk later on about things like breaking the builds and stuff like that. So those results that are marked as not exploitable, they will not participate in all these threshold calculations. Okay, they will still, yeah.
These can be controlled by our background.
Yes, exactly. So not just, that was my next point. Not every user should have the ability to mark the results as not exploitable. Because of the sensitivity of this, those developers or those users who don't have this authority to mark vulnerabilities as not exploitable, they can mark them as proposed not exploitable, and then someone else with higher level of authority can review all these results and make the final decision on the specific results. So that's in terms of the SAS findings. Now let's have a quick look at SCA findings. So with SCA, basically just wanted to show you a specific type of finding. So with SCA, what you get, first of all, the results are broken into several categories. So first of all, you get all of your packages. Now let me show you a bit more of an extreme example. So in this one, you can see that it shows you that we have 1,077 total packages. Now, it doesn't mean that my manifest file actually had 1,077 references in it. In fact, you can see that most of these references, they are so-called transitive or indirect. And if I just want to look just at the direct ones, that's it. These are all the direct references. And the rest of these references, they're all indirect. Okay, so this is the first thing that you kind of notice when you look at the results, because you will see that there are lots of packages that you may not even be aware of. The fact that they are referenced from within your manifests, but they still get imported into your supply chain. Okay. Now, for every package, you can see what's your version, what's the latest version, if it's outdated, if policies are violated. So you can define policies like, for example, no high severity vulnerabilities or not outdated, etc. You can also see the license information. Some of the packages have multiple licenses. Some have problematic licenses. I'm not sure if you guys are familiar with GPL license, but it's problematic because it requires from you to publish your own source code. So, and in many cases, developers are not even aware of the implications of using certain components. So providing this information is important from this perspective. Now, you can also see if the component is actually used or not used. So it might be referenced, but not necessarily used. Okay. Now, this is also important because if a component is not used, but it has lots of vulnerabilities, it may be less urgent to fix that particular component than another component which may have fewer vulnerabilities but used. Okay, so that's also an important piece of information. Now, if you go inside the component, you can actually see how exactly it gets into your supply chain. So sometimes, as you can see, these chains are pretty long, and that's also very useful information. And then we can switch to the risks. So risks, we actually divide them into three categories. So there are vulnerabilities, there are legal risks, and there are supply chain risks. And I'll talk about, so legal risk we already spoke about. So vulnerabilities, so you can see many of the vulnerabilities, or most of the vulnerabilities have so-called CVE numbers, common vulnerability entry. And when you go inside, you can see more detailed description of the vulnerability. You can see links to different articles and stuff like that, and the remediation advice. And basically, in most cases, the remediation advice is to upgrade to the latest version. Yeah, sometimes there is no remediation. Like there could be a situation where a new component, a component with the fix has not been released yet. but you still need to be aware of the fact that it's risky. Now, most of the vulnerabilities have the CVE number attached to them. Some of the vulnerabilities have a CX number attached to them, and this is a Checkmarx proprietary vulnerability as we reported. We do it, so we have our own research team that is looking at what's happening in this area, and they do their own research. And when they find a vulnerability, they work with the international community in recognizing these vulnerabilities as CVEs. But until this is done, and sometimes it's never done because, for example, a component might be out of maintenance or something like that. Yeah, these vulnerabilities get this CX prefix designation. Okay, now what's also very important is that because we possess these two technologies, so we possess both SAS technology and SCA technology, we can provide you with some really unique value add functionality. So we call this the exploitable path. And the exploitable path basically tells you that the specific vulnerability is in the executable path of your code, okay? Because the fact that you import a component and that component has a bunch of vulnerabilities doesn't necessarily mean that you are affected by these vulnerabilities, because this vulnerable functionality may not be used by your software, okay? By combining information from SAST with the information from SCA, we can actually tell you if there is an exploitable path for a vulnerability. So in this case, it actually shows you that this is a vulnerable method which is called from within your code. And sometimes these look really messy, like for example here. We have some exploitable paths that are really, really long. So it's something that is not very easy to detect, but by combining both technologies, you're able to get this additional information from there. Now, we also provide information about containers. So if there is a Docker file within your code, and this Docker file uses a base image or a number of base images, we can provide information about vulnerable components which are included in that base image. So in this particular case, we have, I think, one base image. And from what I can see, it has no risks. Oh, it actually does have some risks. So it does include some components for which we know that there are some vulnerabilities. And this actually could prompt you to update the base image that you're using, okay? So this is something that we're working on now. Thanks for asking this. So we've been asked this question a lot about doing automatic remediation. So if we look at this subject as a whole, okay, providing automatic remediation for SAST is not easy, because you saw that implementing a different logic and stuff like that, it's not something that can be easily done. But for SCA, in many cases, it can be done fairly easily. So we can actually provide you with information about how this can be done. So in some scenarios, we have these remediation tasks that can tell you how to fix. And it basically shows you step by step how you can modify your package files or manifest files. To reference the images or to reference the components that don't have known vulnerabilities or the latest version, etc. Now, the next step will be doing this automatically. So this is something that we're working on, and it will be released fairly soon. So we're talking about within the next couple of months. Yes, so another thing that I wanted to show you, and this was just before I was about to jump to the IDE. We actually already released an IDE plugin for IntelliJ, which has this dependency checking functionality. So unlike SAST, for which you pretty much have to run a scan on the server because it requires lots of computational power. For SCA, you can do the scan inside the IDE. And what you get there is a report like this. So basically, it shows you all the vulnerable dependencies, and it shows you the badge here basically corresponds to the highest level severity vulnerability that is reported for that particular component. And then when you stand on a component, you can see all the references to the vulnerabilities themselves. And you can click on the link there, and you will be taken to the Checkmarx advisory on that particular vulnerability. Okay, I'm not sure what happened here, but that's the idea in any case. And the next step for this kind of plugin will be automatic remediation as well. So it will basically suggest you to replace the references in the package file. Okay? Yeah, exactly, yes. That's the idea, okay? Now let's jump back to, so the last piece that I wanted to show you with regards to SCA is supply chain risks. So on top of regular vulnerabilities, we also are capable of reporting supply chain risks. So supply chain are newer kinds of risks that started appearing more and more in the recent couple of years. It's basically attempts by malicious parties to get malicious versions of the components into your supply chain, pretending to be genuine versions of the components. And they use multiple techniques to do that. They use things like typo squatting, for example. So they name their components very similarly to the genuine ones, hoping that one of your developers will make a mistake and they will get the malicious component. Or they can be just stealing credentials from the valid open source contributor and releasing components pretending to be them. And actually, tomorrow I have another talk on this particular subject, going much more in depth on supply chain in general. But what I wanted to show in this session is that our SCA is capable of reporting supply chain risks. So this obviously is not a real-world example. It was constructed to just showcase some of these malicious components. But yeah, if by any chance you've got a component like that as a part of your supply chain, it will be reported, and you will be able to see it as a result within the results of your SCA scan. Okay. So the last piece that I wanted to show you with regards to scanning is infrastructure as code. So I've got some examples here for Terraform. So basically, with infrastructure as code, first of all, we have this website dedicated to it. We called the component that we released for it CxAST. It can actually be used standalone. It can be used without the Checkmarx platform. We called it CxAST, keeping infrastructure code secure. And it can be run on its own. It's open source. You can download it by yourself, and you can integrate it into your environments just by itself. There is a big section on integrations here as well. So these are all the environments that we documented how to integrate it into. But in terms of what it supports, these are the environments that it currently supports. And as you can see, it's a pretty impressive list of different environments. And per environment, if you go to, for example, Terraform, you can see all the types of security misconfigurations or weaknesses that CxAST is capable of identifying. Okay. So within the AST platform, the CxAST scanning is already built in. It's already embedded. So when you run a scan, you get the results like this, and this is how the typical results look like. So the look and feel is pretty much similar to the SAS scanning. The results are reported in this way. And as you can see, it just tells you, okay, this is the particular issue, and this is how it's supposed to be fixed in most cases, and you can take it from there. Now, speaking of IDE plugins and automatic remediation, we're actually about to release a plugin like this for Kix for Visual Studio Code. So this will be the first plugin supporting automatic or semi-automatic remediation of Kix findings. Why semi-automatic? Because in some cases you can do a pretty certain fix automatically, but in some cases, like for example, if you want to limit network range, so network rules, you want to have it defined, but you need to define it to a specific value, right? So you need to provide a value there, and it cannot be suggested automatically. So we can provide some skeleton for the fix, but the actual content of the fix needs to be input by the human.
Are you guys planning to look into Palumi?
Sorry, for what?
Are you guys planning to look into Palumi?
Palumi?
Yeah, which is like Terraform on steroids.
I'm not sure. I'll need to check. Yeah. So what we support at the moment is listed here. So basically, you can go to this docs.kix.io and have a look. So this is what we support at the moment. What's also interesting to note is that it's actually an open source project. It has its own GitHub repo, and you can work on it. You can post comments here. You can request features and stuff like that. So you can provide your inputs here as well. Okay. Now, a few words about IDE integration. So I already showed you some of the plugins. So for example, here we are talking about integrating the results from the AST platform. So you can look at SAS Results in the IDE, and it's kind of similar look and feel. So you have the ability to do the triage from here. You have the ability to jump between different bits and pieces of the attack vector. There is a similar integration with Visual Studio.NET and with IntelliJ. So this is how it looks like, and Eclipse. And it works for different variations of the same IDE. So this, for example, is Android Studio, which is based on IntelliJ, and the same plugin works for it as well. Okay. In terms of integrating into the common CICD environment, so we have integrations with for example, Jenkins and TeamCity. So if you look at Jenkins, so this is my Jenkins pipeline, and if I go into the configuration, when I install the plugin, I can add a step which is called execute checkmarx AST scan, and I just need to provide some parameters here, like the project name and stuff like that, and I can also provide some additional parameters here, like presets. I can also provide thresholds on the command line, which will allow me to actually fail the build if thresholds are, if it's above the thresholds. We have similar plugin for TeamCity. So this is the report from the TeamCity plugin. And there is one for Azure DevOps. So if I just go to the pipelines. Yeah. Yes. Yeah. So again, this is the plugin. I just looked it up on Marketplace and enabled it, and then I can put various parameters here, including the thresholds. Like here, for example, it says what are my thresholds for different types of vulnerabilities, and this way I can customize the criteria. I think that's about it in terms of the overall capabilities. We also have integrations into other environments, so you can use, even for the environments for which we don't have specific plugins, you can use the CLI. So you can invoke the scanning using the command line, and the command line basically allows you to do everything you can do using the UI and even more. So you can trigger a scan, you can list projects, you can get the results, you can do all sorts of things. The CLI is released for all interesting platforms, so it's released for Linux, Windows, and Mac OS, and there is also a Docker containerized version of it, which will release on Docker Hub. So you can embed it into environments for which we don't have native plugins. So for example, some of our customers wanted to integrate into Circle CI or to AWS code pipelines and stuff like that, so that can be done using the CLI. We also provide APIs. So, so this is the Swagger. Basically, you can see that all sorts of aspects of the product can be automated using the APIs. So, for example, projects, there is a whole section of projects that you can operate using the APIs. I think that's about it. We have 4 minutes left, so if you guys have any questions. Yeah.
I went through the Sneak demo, and your product seems very similar to theirs. So
Yes.
what's the differentiation?
So it's no mistake, we compete. Sneak and us, we compete. We kind of come to the same space from different directions. So Sneak, first of all, Sneak are a younger company. They don't stick, for that long as we do. We exist for like 15 years. We come to the, this overall space of covering all aspects of application security from SAS background. So SAS has always been our bread and butter. We have done only SAS up until about 5 years ago, and then we started adding additional stuff, SCA, Codebashing, and stuff like that. Sneak came from the other angle. They came from the SCA angle, and then they started adding additional bits and pieces. I think their SAS piece has been a result of an acquisition that they made about, I don't know, a year ago, a couple of years ago. So I'm not sure how well it's integrated with the rest of it. But look, with regards to the SAS capability, we are, pretty much regarded as the industry leader. So in terms of, if you look at the customer base, we have in Australia 3 out of the big 4 banks. Here in New Zealand, ASB and BNZ are our customers. So, we have very good name, very good reputation when it comes to SAS.
And do you know if people use your product to scan public repos on open source projects and use that to exploit, to introduce vulnerabilities?
Potentially they can, yes. Nothing prevents them from doing that. I mean, if someone asks me what should these maintainers of these repositories do, they should do exactly the same. Look for any vulnerabilities there, and if they find something, patch it as quickly as they can. Yes. More questions? Okay.
Thank you.
Yeah. Thank you, guys.